In this video, I want to talk about more advanced problems that have to do with simplifying rational expressions, okay? So this first example I'm going to show is 1 plus 3 over x minus 3, which is all over 1 minus 3 over x minus 3. And really, our goal should be to simplify the numerator and then simplify the denominator and then see if we can't simplify the entire rational expression. But we have to be able to add rational expressions first before we can even tackle that. So if you're still struggling with that, you might watch the previous video, but that's what we want to start with. So that's what I'm going to start with here. And how can I actually simplify this numerator here? So I have 1 plus 3 over x minus 3. What would the LCD be for that? Well, this is 1 over 1. So that's going to be x minus 3 would be with the LCD. So I can make 1 x minus 3 over x minus 3. So that's still 1 because it's something over itself, plus 3 over x minus 3. Okay? Now I can do something very similar for the denominator. The LCD, I would argue, is also x minus 3 here. So I can make that one x minus 3 minus 3 over x minus 3. Okay. Let's see if we can't continue simplifying. So for the numerator, notice that both of these expressions are over the same denominator. So that means I can write them over the same denominator, which is x minus 3. Okay. So I would have, let me draw a line here. I have x minus 3 plus 3. Those 3's cancel, so I have a single x right there. All right. Now, same thing for the denominator. They're over the x minus 3, and I have x minus 3 minus 3. So that's going to be minus 3 minus 3, which is minus 6. X minus 6, and that is also x minus 3. Okay? If you remember fractions well, you'll know that if you have the same denominator, if you're dividing two fractions and they have the same denominator, you can simply reduce them. I'm going to fully show that that's true, but if you already know that, you know that you can just reduce these. So we could flip the second one, right? We can flip the second one, the bottom fraction here. So x minus 3, x minus 6, okay? And look, we have an x minus 3 on top, x minus 3 on bottom, and it reduces. And that's what I was trying to say here. If you have, if they're over the same denominator, they just simply reduce, okay? What are you left with? You're left with x over x minus 6, all right? Again, I hope that helps with this problem. This is a problem that really gives algebra students a lot of trouble, so I'm hoping that that makes a lot of sense. For any of these problems, please let me know if you're still stuck. Okay, let's look at this one. 4 over a plus h minus 4 over a divided by h. Okay, so again, the idea is that you simplify in the numerator and then simplify the denominator. I'd say the denominator is pretty simplified. It's just a single h there. But for this, okay, well, what would the LCD be, right? So the LCD, we have, you know what, maybe I'll write that over here. That way we can still see it. So what would the LCD be? It's going to be, notice that this is a plus h, so it's not just simply a and h. So it's going to be a plus h. Okay, so that's the LCD. All right. Well, what is this denominator missing? It's missing that a. So we have a plus h, minus, and then I need this 4 to have an a, right? That way we're not lying there. This a is missing the a plus h, so 4a plus h, a plus h, okay, okay? And that's all over h. And we're going to work on that in a minute, but we have to get this over the same denominator. Okay, now what do we have? We have 4a minus 4a, so those are going to cancel, and we'll just be left with negative h on that top, okay? So I'll have negative h over a plus h, and that's over h, okay? Now, if you want, you can think of this h here as having a 1 under it, okay? Almost like it's a whole number. And then from there, you can say negative h, a plus h, times 1 over h, okay? So you can reduce that h totally out. We still have a 1, and we have a negative sign here. So we're going to have negative 1 over a plus h, okay? And that will be the final answer for that one, okay? Again, this is another problem that gives students a lot of trouble. So please let me know if that is still not making sense to you, but that should give you kind of a head start for that type of problem. Okay, let's look at this one. 3 plus 1 over 1 plus 1 over x, okay? Every time I've ever tutored this class or taught a class like this in algebra, this problem always trips up students. So let's go ahead and figure it out. I would say the first thing to do is actually for this problem is to simplify this denominator as much as you possibly can, okay? And how do I know that? Well, some of it's just practice, that this is really complicated. These other parts are super simple. And so my instincts just tell me you've got to simplify this more. Yeah, okay, so let's do that. So I have 1 plus 1 over x, okay, and I want to simplify this. Again, this is 1 over 1, so the LCD is x. So I can turn that 1 into x over x plus 1 over x, right? This 1 over x. Okay, let's put those together. So I have 3 plus 1 over x plus 1 over x, all right? Well, look at this. You have 1 divided by a fraction, okay? That's the reciprocal of something, right? That's the reciprocal of something. So we learned about that with negative exponents. We learned about that in previous algebra courses. So that means I can simply flip that upside down. So that's x over x plus 1, all right? Now we're kind of back to where we were. What would the LCD be for this problem? Well, this is 3 over 1, so the LCD is x plus 1, or 1 times x plus 1. So we'll have 3x plus 1 over x plus 1 plus x over x plus 1, okay? And we're almost done. So we have 3x plus x, that's 4x, and then 1 plus, there's no numeral there, so just 1, x plus 1, okay? And that's the final answer right there, all right? You can skip as many steps as you feel comfortable with skipping for a problem like that, but I think this would be, a good gauge of, a medium style of solving this. So again, please reach out if this isn't making any sense to you, but I hope that this at least helps get started on a problem like that, okay? All right, have a good day.